Hi guys. So this is the Source 4 dimmer. The Source 4 dimmer is a local dimmer that is mounted directly to a Source 4 fixture. The entire Source 4 line can be used with the Source 4 fixture, and what it does is it allows a 230 volt system to use a 115 volt lamp. By doing that, it takes advantage of the more efficient 115 volt HPL lamp to give you up to 35% more light within the existing Source 4 line. In addition to doing that, if you're comparing against other fixtures, a 750 watt lamp can actually be comparable to up to a 2.5K condenser profile. So there's a considerable power savings to be had. Now we're using a new technology that we're calling the electronic silent dimming. Electronic silent dimming gives you the voltage regulation that allows you to be able to power that 115 volt lamp on 230 volt power. It also gives you complete silence, both at the filament and also from the dimmer itself. So at 1 meter, you drop below the 0 dBA audible field. Additionally, we have the ability to control this dimmer locally. So what I did is I pressed the light button. When you press the light button, without a programmer having this patched, you can already do your focusing so you don't slow down the work of your stage electricians. This is built in such a way so that as you're working with more and more LED lights, you can use your local dimming to power your tungsten lights, and you can provide power and data in the same way that you do any of your typical self-dimmed luminaires like LEDs and moving lights and things like that. So now up on the screen, what we have are the comparable outputs. Showing the 750 watt, 230 volt HPL, you see that you have the typical, what you'd expect from a Source 4 in the 230 volt market. On the left is a 575 watt lamp running at 115 volts. It's already brighter than the 750 230 volt. However, if we kick up to a 750 watt 115 volt, you can see the 30% increase in brightness. Going the other direction, coming back down to the 575 where it's still brighter than the 750, and then even further down to the 375, you're approaching the intensity of the 750 watt lamp at 375. So that's nearly a 50% savings. Now it's not quite as bright, but it's approaching the same intensity. With the 575 watt lamp, one of the things that we've done is we've compared to some of the other condenser profile fixtures. And the 575 was brighter actually than the 1200 watt condenser profile comparable zooms. So that's the Source 4 dimmer.
Eric, is the dimmer similar to the sine wave dimmer? How does it, what's the mechanism?
It is similar. We actually are not really talking about the dimming technique as much as we are about the results you get. That's because in the past you'd work with a phase control dimmer or you'd work with a sine wave dimmer, and we started mixing the technology with the technique of dimming. What this does is it's a technique that's very similar to sine wave dimming, but we realized that with sine wave dimming, what we wanted to do originally was to dim any light, and we fell short of that. The whole industry fell short of that with sine wave dimming. With this dimmer, what we're trying to do is we're trying to quiet a tungsten fixture and give the light a brighter output. And so by making a few compromises, what we're able to do is to provide a new dimming style that's giving the same benefits for a tungsten fixture as you would get with a sine wave dimmer. Complete silence, but then also give it the ability to regulate to 115 volts. In regulating to 115 volts, now you get that extra output of the Source 4 that you would get in the US here in Europe.
Is it a linear load or a non-linear load?
Well, it becomes very linear at intensity. When you're sitting at quiescent draw, it's about 3 watts of quiescent draw, but then it is not a linear load. Just like other power supplies, LEDs and other things, at that point it's actually drawing a little of reactive load, so it's a low power factor.
If the switch fails, can it blow the lamp?
How this works is much like the sine wave dimmers that we've built in the past, it has internal protection. So electronically it's able to shut itself down. Then we use RDM messages to send that message remotely to the console and to tell you that the lamp is blown, or if you've if you've sent it, sorry, if you've blown it up, certainly then you get the lamp message. But then if you happen to connect it to a lamp that's too large and you're drawing too much current, it has a message that it'll send for that, and it'll shut itself down preventatively for that as well.
Are physically the bulbs the same? So is that if for any reason you had a weird mixed rig of 115 and 230 bulbs, is it an easy thing to do to put the wrong thing in the holder?
Yeah, physically you can switch out from a 115 to a 230, so it's very easy there. Additionally, if you happen to be on tour or in your system you run out of 115 volt lamps, we do have a method of switching over to 230 volt output. So in that case, you do a special function. It has you confirm that to make sure you really wanted to do that function. And then you can use the lamps that you have been used to using in the Source 4 line all along.
You do that on there?
And you do that directly at the fixture.
So you
now,
can just use it with a standard 230 volt lamp?
That's right. You can use it with a standard 230 volt lamp.
What's the efficiency of this?
It's running right close to 95%. I think it's around 94%.
And how much is the box weigh? I presume it's mostly copper.
It's just under 2 kilograms. Yes. It's actually 4 pounds. I can think much easier in terms of pounds. So.
Is the lamp life between those two voltages and with this type of dimming?
Yeah, actually the 115 volt HPL runs at 400 hours with the high output version, and then there's a long life version as well. But so you do automatically, as part of moving to the 115 volt lamp, get an extra bit of life out of that lamp.
Similar technology to what you had in the sine wave dimming, but it's
similar
with some compromises.
Yeah, but one of the things that you do with sine wave dimming, or what we wanted to do with sine wave dimming, is we wanted to be able to dim any dimmable load. Well, how it turns out is that that was probably an unrealistic expectation.
And with too much.
Right, because really for the money that you're spending on a sine wave dimmer, the best application for it was to quiet a tungsten load. And so when you start thinking about in terms of what you're trying to do, just quieting a tungsten load, you can make some compromises, and that's what we've done here.
But it's built from the same technology.
Right, right. Very much the same technology. It's using transistorized dimming.
And the power draw when it's quiescent is to do with the smoothing, is that right?
It's actually having everything to do with the fact that it's power supply driven. It's a dimmer that has a power supply in it, and the fact that it's CE compliant. So once you get CE compliance, it takes a little bit more draw when you're at zero.
There's going to be like maybe possibly multi-channel versions of this for rack mount and things like that, I guess?
We're not planning on having a centralized version of this. This is really meant to send us in the direction that we believe the industry is moving.
But what about like a 4-channel or 6-channel that you can put on your bar? I mean, that would make some savings.
That's actually a great question. Now, the reason we haven't done a 4 or 6-channel version is because we believe that the system design itself is changing. Yeah. As system design moves more towards having LED, moving lights, and tungsten all side by side, we believe that intrinsically there will be less and less tungsten fixtures sitting side by side in large numbers. So to put a bar of 6 tungsten-oriented dimmers side by side might not be a wise system design. So replicating that for cost savings actually might not be giving you the cost savings that you might otherwise think.